Welcome to today's office hour, Building a Cloud-Native Stack with EMR Spark, Alluxio, and S3. My name is Amelia, and I will be your moderator. Before I introduce you to our speakers, I've just got a few housekeeping items. All participants are automatically on mute throughout the session. We will be using Slack to communicate, so please take a moment to join us on the community Slack channel, which is alluxio.io/Slack, and it's also posted into the chat box in your GoToWebinar control panel. However, if you are having trouble joining Slack, feel free to message me your questions instead, and I will share it with the group. Today's session will be split into a quick presentation followed by a really cool demo. We will have a Q&A session at the end of each section so we can answer all of your questions. To ask a question, recall join the community Slack channel posted into the chat box. Lastly, today's session is being recorded and will be available for on-demand playback. We will email you the link to the presentation as well. That's it on the housekeeping side, so let's meet our speakers. We're very pleased to welcome Bin Fan, who is the founding engineer of Alluxio and the PMC member of Alluxio Open Source Project. Prior to Alluxio, he worked for Google, where he won the Technical Infrastructure Award, and he received his PhD in computer science from Carnegie Mellon University, working on distributed systems. Joining Bin, we have Nakkul Sreenivas. Prior to Alluxio, Nakkul worked as a consultant where he built and supported an entirely open source Hadoop platform for financial services clients. Without further ado, I'm passing it on to Bin.
Thank you, Amelia. Hi, everyone. Good morning. I'm very glad here to jointly host this monthly office hour with Nakkul, talk about how we can build a cloud-native stack with EMR Spark, Alluxio, and S3. This is a very cool stack. And for one experiment we're doing here is we're trying to use the Slack channel to answer all the Q&A, the questions. So if you have any question during the talk, please feel free to post your question into the community Slack channel, and we will answer them in the end. And also, if you have any trouble with registering with our Slack channel, you can always send a message to Amelia, and she will help to share with us. So in this way, you can always, even after this presentation, after this webinar is done, we can always go back to the Slack channel and retrieve the history. Okay, so let's start. I just quickly jump into this topic. In this particular presentation, we will talk about how to build a very efficient, why we want to build this very efficient, and how we can build this efficient cloud-native analytics stack on AWS. The first of all, everyone nowadays has heard about AWS S3 because this is almost the default data lake on AWS. Everyone loves it because it's very cheap, it's always very high available, and it's always fully managed. You don't have to put any you don't have to have any maintenance or work around S3. You just always get capacity and use it. And also it can scale to a very large scale because Amazon is behind running this service for you. However, there are also quite some limitations, or I will phrase this as a difference between S3 as the object store versus a traditional distributed file system. These limitations include a slow object listing and expensive rename operations. So in a traditional or conventional file system land, a rename operation is typically a metadata operation, and it's considered relatively cheap. And it's also atomic. And because of this characteristic, a lot of big data analytics is using rename operation is one way to commit to do some atomic commit to mark this is the result or final result for certain task. However, this is no longer true, or this becomes very expensive on S3. And also we see from time to time people are complaining, oh, we have this throughput throttling happening on S3 because my job just kicks too much data retrieval from S3. And on the S3 side, there's some mechanism triggered, and they will just throttle this throughput between S3 and the application. What's unfortunate is a lot of applications, big data applications, they do not have this throttling, the throughput throttling in mind when they are designed. So and this can brings a lot of issues when you just run these applications naively directly on S3. And one other thing we see in a lot of tests or some production runs is we do observe a variable performance across different days or even within the same day across different hours uh, about the speed you're reading from S3 or downloading from S3. On the application side, because S3 is separated from the computation, you run your computation perhaps on EC2, and S3 is a different service from AWS. So there will be no data locality on the computation side. And even S3 itself is nowadays is very advanced. The storage is a very advanced storage, has many different components and has hot tier or cold tier. But this is not user facing, and you are pretty much using this transparently as a black box. So if you understand your workload much better and you want to enforce some user managed policy in terms of like data TTL or data preloading, and there's no way for you to achieve this with a black box, with storage in the black box. So that's why we're building Alluxio, or we're promoting put Alluxio in this use case as a data orchestration for the cloud. So Alluxio is not a storage and it's not a computation framework. So instead, Alluxio is a new layer inserted into this data stack. On our top, these are applications talking to Alluxio through one of their favorite interfaces, including HDFS or S3 or even our native Java API or some POSIX API preferred by some trending deep learning frameworks. On our bottom, we are able to talk to variety of different storage systems, including S3 or Azure or GCS or HDFS or some other storage from different vendors. And we have already built different drivers or connectors to different storage. So in this case, you don't have to choose, and you don't have to manually change the library or the version, and we will do this for you. So in that way, we're building a abstraction of the data, file system data or object store data for the applications, and they can choose whatever way to access it, and that's the abstraction, and you can do a lot of data policies inside this new data orchestration layer. So let's put Alluxio in the context of AWS or as or building some cloud native architecture. So what you can get the benefits you can get from having Alluxio in this picture includes the following few different bullets, including providing a better or consistent performance because Alluxio can be used as a data cache layer on top of S3. So you can both cache the hot data, but also the metadata part. In this way, Alluxio can provide you the familiar file system semantics, including efficient listing and efficient rename operations. Well, one of the reasons we can provide familiar file system semantics is Alluxio is implemented as a file system. So we are maintaining the full feature file system metadata service in Alluxio land. So that's why once we understand this metadata from S3, and we can continue to serve all the metadata from Alluxio namespace. And also, because Alluxio can cache data, and once Alluxio is co-located or getting at least deployed close enough to the applications like Spark, and we can bring back the data locality. One key design point for many Hadoop applications like MapReduce or, for example, like Spark or Presto is to leverage the data locality as much as possible with Hadoop file system interface. Applications can query the data to understand where the data is stored from a storage. And then the scheduler like a Yarn or a Spark scheduler or a Presto coordinator, they can smartly locate or place the task closer or co-located with the storage, the node of storage where the data is serving. So this is a key idea of moving computation to data rather than the vice versa. However, in the architecture, if you're building a cloud-native architecture and using S3 as the data lake, and this cannot be achieved because S3 is always remote to the applications. So by having a layer like Alluxio, and we can cache the data and also report to scheduler the data location in Alluxio land. So applications like Spark or Hadoop or Hive or Presto, they can leverage this data locality information and restore the data locality and get a much better performance. The last point to have Alluxio is you can also mount different storage, like data sources, into the same file system namespace. So if you're running in a relatively complicated data environment, you're not just running on AWS, but also have GCS or Azure or some other HDFS, on-premise HDFS, you can pretty much mount these different systems just in the same way as you put a S3 as an underscore in the Alluxio land. And applications just assume this is a data abstraction, and without really worrying about how do I connect to GCS, how do I download to Azure, how do I write to HDFS, what's the version. And also you can just mount different S3 buckets. It's the same like as AWS, in some AWS service, but with different credentials into the same file system namespace, and make the management much simpler, because we know from time to time in AWS you have per S3 count, AWS account throttling or the cap in terms of performance or number of files created, a lot of limitations associated with one single account. So in this way, you can also get rid of this limitation by merging different S3 buckets into one single namespace. I want to just briefly talk about what is Alluxio. This was a research project before in UC Berkeley MLab as the PhD thesis from PhD student Hao-Wen Li at that time, who is now Alluxio CTO. And we open sourced this project in 2015 and established a company behind to move forward with open source and to make sure there's a team behind this project. We get support from Andreessen Horowitz, and we get picked from different media coverage as listed below. It's an open source project. We get more than 1,000 different contributors all over the world on GitHub. We have more than 4,000 GitHub stars. The license is under Apache 2. So this is the most permissive license, and it's very common in the big data space. We are having a community Slack channel, and just if you want to ask any question for this office hour, please register on this Slack channel, and we can just iterate from there. And you're welcome to contribute to our source code, and this is a link to the GitHub repository. So I want to give very high-level overview into the features you can do with Alluxio, including, for example, the data caching part. And you can just have Alluxio as one layer on top of S3 or GCS. And we can also manage not just like a RAM disk, but also SSD or hard disk resource, and make them as a black box and migrating data from one tier to another. And in this way, you can allocate even more resource to a storage resource to Alluxio, because if you have like the constraints in how much memory you can allocate, and this will Alluxio will make sure we put the data, the hot data, in the top tier, and relatively the warm data in the second tier, and also the cold data in the last tier, or even evict this stale data out from Alluxio space. And one key difference between Alluxio and other distributed storages like HDFS is Alluxio does not aim to provide data persistency or data durability. So in case the data is stale, the data can be evicted out from Alluxio space. On the other hand, if the data is very hot, Alluxio can transparently and make many more replications based on the data access pattern and move this data around to closer to applications. So in this way, we present data in a way more friendly, more efficient, can be more efficiently consumed by applications to the computation side. So we also provide different popular APIs to applications for Spark, Presto, these applications, they typically assume this is HDFS. I'm talking to a HDFS. So what you need to do is to simply replace HDFS scheme with Alluxio inside this URL. For some applications, assuming there's a POSIX interface, we also provide integration through Fuse. So you can mount a Alluxio service into your local file system as basically applications will see this data in Alluxio as a local file and access this file using your familiar bash semantics or using, for example, TensorFlow or PyTorch, these kind of deep learning frameworks to access the data. We also provide a Java API, so you can just continue, if you want to get a full feature from Alluxio, and this is the Java API provides you the opportunity to leverage every single function provided in the Alluxio space. Yeah, so lastly, we have the data abstraction. We're providing the data abstraction to applications. So for example, in this figure, in the middle, the blue part is the Alluxio namespace. You can think this is a logical file system and backed by two different physical storage. One is S3, one is HDFS, and the HDFS is treated as a root directory, and S3 is mounted as one of the nested directory under root. And you can just run a single command, Alluxio fs mount, by bringing the data from S3 into this logical namespace. So the benefits including you can just let applications being storage agnostic. You can just leverage this to enable hybrid cloud or multi-cloud, or even having more advanced data policies, data migration operations by introducing this new indirection, new layer. And typically Alluxio is used, we see a lot for a cloud analytic caching. So if you're running in AWS or you're running in, for example, Amazon or Google or Azure, you can use Alluxio as a caching layer for applications to speed up and also avoid reading the same data repeatedly if you have data locality in the data access pattern. Another common use case we see is to enable the hybrid cloud. You can, for example, put Alluxio with computation in the public cloud and keep your data on-premise in your private HDFS client, HDFS cluster. In this case, we see a lot of financial institutions, they do have some regulation or some safety concerns, and they just try to preserve put their data in their own on-premise data center and burst the workloads into public cloud. So in this case, they can leverage the elasticity to have this elasticity to run applications, run computation in the public cloud, and you can use Alluxio to improve the data access efficiency. So we see also different ways to deploy Alluxio. So one way is to have Alluxio co-located with applications like Spark and put Alluxio worker with the Spark worker in the same instance. So in this way, a special mode called short circuit read and write will be enabled. So Spark can read from Alluxio without going through network. And this helps applications like Spark to achieve the best performance because Alluxio API will work with Spark scheduler to inform the task scheduling and try to achieve the best data locality without using network. So this is when you want to get the best performance, this is the way you want to deploy Alluxio. And actually, this is the way we're running EMR with Alluxio. This is by default how the Bootstrap is doing. Another way, if you have multiple different applications or computation talking to Alluxio, we also see cases people running Alluxio in a standalone mode and let different applications or different even like EMR clusters talking to this standalone service. The benefits of this is you can leverage the results cached in Alluxio from previous runs or some other applications. The downside is now all the data retrieval goes through network, and you may see less performance compared to the short circuit read and write. So that's the quick overview for Alluxio, how to use Alluxio, what kind of benefits you can get by having Alluxio working in the AWS. I will handle this to Nakkul, talking about how you can use EMR with Alluxio, but also do a demo to show how Spark workloads can benefit from Alluxio.
Before we go ahead with the demo, we have a couple of questions from folks. Our first question for Ben is, what are the options available for data access, authentication, and authorization in Alluxio?
That's a very good question. So so in Alluxio namespace itself, we provide simple authentication. Well, it's called simple authentication, that's the name, but it actually is basically a Unix compatible way to encode the security and the user and group. Essentially, we inside Alluxio maintains the user and group and the permission bits for Alluxio, and we can provide authentication by authenticating with the local Unix or Linux system. So that's the default way. And we also provide some other like Kerberos authentication, which is in the enterprise offering. And we also provide interface called customized authenticator, so you can implement your own authentication.
Great. Here's our next question. Does Alluxio support data locality when both Alluxio and Spark are running on a Kubernetes cluster?
Yes. So I think this is a great question. Kubernetes is basically a new environment, relatively new environment to big data workloads, including Spark or Alluxio. So the way we recommend Alluxio to be run in Kubernetes is through daemon sets, and that will help Alluxio being running on every single node in the cluster. And in that case, if Alluxio is already on every single node, and so no matter where Spark workloads are allocated to, Alluxio can help cache data to these local nodes and like move data around to achieve data locality and also inform the scheduler of Spark. I think we submitted a patch to Spark before to make sure the Spark scheduler can pick up the right locality information when running with Alluxio on Kubernetes environment. But on the other hand, if you only run Alluxio on a subset of the nodes in your Kubernetes environment, then this may not be fully achieved. The data locality may not be fully achieved because you may run Spark totally on the remote nodes to Alluxio. So it really depends on how you're setting. Yeah.
Great. Another question and a reminder, if you're having trouble logging into Slack, feel free to message me your question instead. Another question here we have is, does Alluxio provide high availability mode?
Yes, Alluxio provides high availability modes by, we provide two different modes to provide high availability. One is to run one is to run multiple Alluxio master service, but also configure this master service to connect to a Zookeeper. So the Zookeeper will help coordinate across different masters and select the primary master. So this is one mode which has been there for a long time. In the latest 2.0, we're introducing a new mode based on the self-managed quorum based on Raft protocol. And in this way, you don't even need to depend on external service like Zookeeper. So different Alluxio masters will coordinate with themselves and decide which one is the primary master.
Great. And the last question for this section is, can we run Alluxio outside of EMR?
Oh, yes. You don't have to run Alluxio within EMR. Instead, you can put Alluxio as a standalone mode, as I showed in the previous slide. And in that case, you can always go through Alluxio as a standalone service and make one EMR cluster benefit from the previous EMR cluster, the results. Yeah.
Perfect. We're going to go ahead and move on to the demo session. And in the meantime, if you have more questions, we will address them towards the end. We'll have plenty of time for Q&A and any other discussion you guys would like to have.
Okay, great. Hi guys, this is Nakkul. Thanks, Ben, for the overview on the Alluxio service. Saved me trouble from having to go through it. So I want to briefly talk about how we can use Alluxio with EMR. And as a brief intro, just for anyone that isn't familiar with EMR, EMR is Amazon's provided service that stands for Elastic MapReduce. What Amazon does is, instead of having to manage all the deployment of EC2 instances and installation of all the Hadoop services by the user, Amazon manages all of that infrastructure and deployment for you. So you basically log into the EMR service console, and then you just, with a few clicks of a button, you can actually have Amazon deploy a full-fledged Hadoop cluster with a series of services that they offer. So they offer things like Spark, Presto, Hive, just vanilla Hadoop MapReduce, and I think there's added ones like HBase as well. And you can actually have Amazon deploy this entire cluster and also manage the cluster for you, in the sense of if a node shuts down, then Amazon can reprovision. You can resize the cluster as well. And there's a bunch of various options that EMR actually exposes to the end user via certain APIs. So the question then becomes, okay, well, how would I use Alluxio on EMR? So Amazon provides their own in-house services for Presto, Spark, and so on. But they also offer a bootstrap entry point, which is basically just the ability for an end user to pass in a shell script. And this script basically runs on all of the EC2 instances before they install the Hadoop services for you, which is a perfect chance for you to sort of set up Alluxio on EMR. So what we did was, we here at Alluxio, we wrote a bootstrap script that does all the work of installing, configuring some bare bones Alluxio and setting it up for you on the EMR cluster. So that way you can have Alluxio set up alongside Spark, Hive, MapReduce, and all the other compute frameworks that EMR provides. And the way this works is you basically download the shell script or bootstrap that we have hosted in a few places, and then you place it in an S3 bucket, or you use the one that we hosted in our own public S3 bucket, and then you append this bootstrap to your create cluster command, and then you run the create cluster command with a few arguments. So our bootstrap actually takes in a few arguments. It asks you for details on which underlying file system UFS that you'd like to mount, which S3 bucket you'd like to have backing the Alluxio storage, and then added details for like different security types, different write types, different block sizes, a bunch of different tuning parameters that the end user can specify. A sample command, which I'm going to show, and then I'm actually just going to sort of what the script would look like. And you basically have an EMR create cluster where you specify your version, how many instances you would like. So this includes the master plus the number of workers, the instance type, which applications you would like EMR to install, the name of your cluster, and then this is the core part that installs Alluxio, which is your bootstrap actions, followed by the actual bootstrap script, and then all the different options that you want to specify, or what kind of arguments you'd like to provide to the script. I'm basically installing right now a very vanilla Alluxio cluster. So all it does is set up the root mount for the Alluxio cluster, and then we can just run this. I'm going to run this. It takes about 10 minutes for this cluster to start, so I'm going to switch to a different cluster that I ran beforehand. But basically, if I ran this script right now, I would see a response from Amazon's endpoint, basically giving me an EMR cluster ID. And then if I go to the console, I can see this cluster ID and its status as it sort of goes through the different steps. So I can just go to here.
Okay, while Nakkul is setting this up, we have another question here, which is, can we run multiple Alluxio clusters at the same time on the same underlying S3 bucket?
Interesting question. You can, but there are some considerations to be taken into account. So if you have the same underlying S3, you can only have one, or you only should have one Alluxio cluster writing to this S3 at a given time. You can have other Alluxio clusters reading, but basically any operation done by the first, one of the clusters will not necessarily be picked up by the other Alluxio clusters. So you could have one cluster doing writes and writing objects, and the other Alluxio cluster mounting this S3 like read-only, and then sort of picking up any newly written data objects. But you wouldn't want to have two different Alluxio clusters writing to the same S3. Okay, so for those of you that can see the screen, you should be able to see that I have two clusters here. This one is the one that I just kicked off. And then here's the one that's already ready, which I'm actually just going to log in and sort of demonstrate what it looks like when I logged into my cluster. So let me pull the master hostname. So this is Amazon's wonderful ASCII art, which will also show that we have various services installed. So I can see the Presto CLI is available here. And then the easiest way to validate that Alluxio is running is I can just run the Alluxio run test command. This is sort of an inbuilt command that sort of tests that, makes sure that we can do all of our different writes, different reads, write to our underlying S3, and so on and so forth. And we can see that all the tests have passed, which means I'm actually just going to give a quick overview of what I've set up here on the Alluxio cluster. At the moment, I have a TPCDS folder. For those of you that are familiar with this, this is a standard benchmark data set that's used for testing different SQL engines. And then in here, I have a Parquet folder where we have various different scale factors of data. So if I look at the scale 100, I can see I have various different tables here. So now what I can do is I can actually go to Presto, where I've defined these tables. And I can use the Presto CLI to query these tables. So if I choose my Alluxio database, and then I can actually start by showing the tables and then showing how I've defined these tables. So you'll see that the call center table has all the various different fields, and it defines an external location as Alluxio with the path specified towards the call center data set. And now what that means is I should just be able to do this. And we can see that the query completes pretty quick. As Ben was mentioning before, Alluxio does offer a caching service. The reason this query completed pretty quickly is because this cluster has already queried that data set. If I choose a different table, maybe one that I haven't created or one that I haven't queried before, so I think warehouse might be a good one. So I can start by querying the warehouse table, and this should be a little slow, but then hopefully when I rerun it again, warehouse might be a little too small of a table. Let's try web sale or web returns. Okay. So the first query generally tends to run a little slower, but then over time, as you continuously query the same data sets, you'll see that the results come quicker and quicker as Alluxio caches the data in our own, and you can see that we went from 10 seconds to 6 seconds. And of course, this changes based on the number of nodes, how much RAMFS or how much memory you configure as your worker caching tier or your different storage mediums. But the performance is basically based on the frequency of read operations on a given table, and Alluxio will cache accordingly and make sure that those blocks and that data is available in a much quicker to the end user. And another consideration to take into account is when you're using Alluxio on EMR, especially when AWS's pricing model is based on the amount of data transferred. So generally within your region, data transfer from EC2 to S3 is free. But then if you go cross region, so if you're querying an S3 bucket in a different region, then you may end up paying some data transfer fees. Or if you're transferring data in from like an on-premise S3 storage, then you'll definitely end up doing inbound data transfer fees. And Alluxio sort of saves you the amount of fees you'll be paying by caching this data in the EMR, the EC2 instance itself. So if I were to query the table more than once, then I would only end up paying for the first time that the data was pulled in and stored and cached on the EMR. I wouldn't have to pay multiple times if I ran the same query again and again on the same table. This not only applies to the data transfer fees as well, but also the number of S3 metadata requests. Every time you make an S3 put, get, or head object request, Amazon keeps track of the costs associated. So one way to mitigate that is because Alluxio is also caching the metadata of the file. So like the file name, the file path, the file extensions, block size, and all of that, then you actually end up paying less for the number of S3 metadata requests you make as well. And this has been mentioned before, because S3 can sometimes, depending on the region, have varying performance and doesn't have a guaranteed like throughput based on the amount of usage that it's seeing at a given time or of day. Alluxio offers a little more stability and guarantees in terms of the I/O and performance that we provide. I think that is the majority of what I had for today's demo. If there's any questions, it looks like there's a few on the Slack channel. Go ahead.
Our first question is, when moving data from HDFS to Alluxio file system, where Alluxio is a standalone cluster, does Alluxio communicate with the HDFS metadata to get the information on data locality?
I see. I think I should start by clarifying the data locality concept. So generally, when we talk about data locality here, we're talking about the locality between our compute nodes and the Alluxio worker nodes. So we try to increase that locality because we want the data to be available to the compute as fast as possible. Now, in the scenario that I think is being described here, the question is more about data locality between the Alluxio worker and the underlying HDFS data node and the storage there. So we will try to enforce some level of locality when we talk to our underlying FS, assuming that the data node and the Alluxio worker are co-located. But I think for more details, I think Ben probably knows a little more about the level of locality we offer.
Yeah, so for the HDFS particularly, there is some optimization we added. So it's a very interesting case because HDFS is also offering the similar concept of data locality. So assume the data is already in Alluxio land, then it has nothing to do with HDFS. Alluxio will just report to applications where data is stored. So the interesting case happens when the data is not in Alluxio, but also on but stored in HDFS. So two cases. One, HDFS is remote from Alluxio. Then in this case, there's no way for Alluxio to bring the HDFS locality there because anyway the data is remote. We will just fetch data and serve this to the application. However, if HDFS is also co-located with Alluxio, Alluxio will guess or consult with the HDFS metadata service and report the HDFS data locality to the applications and cache data there. So yeah, so in that case, yes, we do talk to the HDFS metadata service to get the locality information.
A follow-up here, which provides the better performance, Alluxio installed on each node of the Hadoop cluster or Alluxio installed as a standalone cluster?
I see. This is also a great question. Actually, let me clarify here. So essentially, our target environment, our target workloads is not a co-located Hadoop cluster, although Alluxio can work there. But I don't think that's our target environment to work. In order to get the best benefits from Alluxio in terms of performance, typically we see users have a remote data source, a remote Hadoop, or it's a remote cloud storage, something like this. And that's the case, I would suggest you to deploy Alluxio to boost the performance. If you have the Hadoop cluster and if your application is already co-located with the Hadoop HDFS cluster, unless you have a really HDFS, which is the performance is really bad. Otherwise, I don't suggest put Alluxio there as an extra layer between Hadoop and Alluxio. That being said, we see a case people typically also deploying Alluxio is they have a Hadoop cluster, but you have to run a satellite cluster for some resource allocation or resource isolation reasons, a satellite cluster running Presto or Spark, and you don't want to repeatedly pull data from Hadoop to this satellite cluster. And then we see from time to time people put Alluxio as a proxy for the Hadoop data in that satellite cluster. So that is actually pretty common. Yeah. So, but essentially, if your application is already co-located with Hadoop, unless your Hadoop has really bad performance because the name node pressure or the disk is unstable on your data nodes, otherwise, I don't suggest to put Alluxio there.
Yes, great. So our next question is, can you talk a little more about how Alluxio addresses the S3 rename issue, specifically when checkpointing or writing data frames out?
Yeah, that's a great question here. We provide, Alluxio Land also provide a full feature metadata service. So we provide a interesting optimization here that, let me step a little bit back. A lot of applications like a Spark or MapReduce, they use rename as the final step to commit some data or a different attempts for a task and the writing data to the final destination. And once one attempt succeeds, the worker will just try to rename this temporary data to the final data location. So that's how it is typically used, the rename as a commit. So in Alluxio, we have the mode that you can write data asynchronously to Alluxio, and then Alluxio asynchronously propagate the data to data storage like S3 or some other storage. So in this way, you don't have to wait for the compute for Alluxio to complete the persistence, and applications can proceed, and the data will be available in Alluxio as long as the writes complete in Alluxio land. So we also have in the 2.0 release, we have a very interesting optimization that we persist the data only on rename. If you turn this flag on, we will persist the data. So before you rename the data, we will not persist this into S3 because this highly likely this is some temporary location. And once the user tells Alluxio, let's do a rename, and we view this as an indicator, okay, this result becomes final, and let's persist this data to S3. So in this case, we just need to do one persist rather than one persist plus one rename on S3, which can be 2 copies. Yeah, so that's one way we can do this. And also, we see typically in the 2.0, we have a new feature. You can set different, by the way, we have different write modes for applications. You can tell Alluxio, I want to write this using the modes writing to Alluxio only, or I want to use the modes writing to both Alluxio and S3 synchronously, or I write to Alluxio first, then Alluxio asynchronously write to S3. That's the mode I mentioned previously. So given all these different modes, it's possible that you can set in this directory, I'm going to use this write mode because this directory is going to be the temporary data, but that directory is the final data. Okay, once you write into that directory, I want to use write through. That's another way you can set, you can enforce data policies inside Alluxio to reason about different ways to persist the data. Let me just ping in one latest blog post from our team members regarding different modes to write, and I think that will help.
Okay, while we're waiting here, we have another question for Nakkul. What are the options available to persist Alluxio cache between different EMR runs?
I see. So when we talk about the Alluxio cache, I think there's two parts that need to be considered. One is the actual metadata that we maintain about the different S3 objects, and then the other is the actual worker cache. For the metadata, we do provide a backup. So we have a backup command that will store a backup of our Alluxio journal and our snapshot of the S3 metadata into a location in S3. And one of the newer versions of our EMR script that's coming out pretty soon will have a simple flag that you can enable. So whenever your EMR cluster terminates, it'll take a backup and store it into a pre-specified location. And then on the next time you start an EMR cluster, you can restore from this backup. The other question about the cache is the worker cache. At the moment, the worker cache does get cleaned between different runs. So if you have an EMR cluster and you want to maintain your cache blocks between different runs of the cluster, then one way is you could copy whatever is in the worker directory, which is in /data or MRFs. Or you could alternatively, you can just have Alluxio rebuild this cache when you start a new cluster, and then whenever you read data again, Alluxio will repopulate the cache. So both of those options are sort of available, and they'll come out with the newer EMR version script that we have.
So does Alluxio encrypt the data when the data is in motion?
So encryption, there's sort of a twofold answer for there. So the first one is whether or not Alluxio supports TLS, so over-the-wire encryption. The answer is yes, but in our enterprise version. So our open source edition doesn't have TLS support, but our enterprise edition does support TLS certs. You can configure them so that all traffic is encrypted from our client to our data nodes and so on. And then I think there's another aspect, which is do we actually encrypt the data itself when it's stored on the underlying S3? And for that, we do have an offering, which is also in our enterprise edition only, which is KMS integration. So it's called, we call it end-to-end encryption. So basically, whenever you read your data or you try to write your data, Alluxio will automatically talk to the KMS that you configure, encrypt the data, and then store the data in S3 encrypted. And in order for you to read these blocks, you need to, again, read with the Alluxio client, which will then decrypt on read as well. So those are sort of the that's the twofold answer to that question.
Great. Our next question is how to monitor Alluxio master/worker health.
A few good ways of doing that. One good way is definitely you can use the web UI. So the Alluxio master has a web UI at the 19999 port. And that port generally gives you good details and information about the health of the cluster. So it'll tell you if you've lost any workers, if any workers aren't reporting, how much cache is being used on each machine, and so on and so forth. And now, the question, of course, is if your master goes down, then where's the web UI? And one of the ways that we monitor, that I've seen in production for monitoring Alluxio is you generally have external services that handle like systemd or a process watch, watchdog, things like that, that'll monitor to see if the process is up and running. And then if it's not, then it'll send out alerts and so on. So for worker monitoring, you would use the master and the web UI, but for monitoring the master itself, I think it would be more done by a third-party tool.
So we, in Alluxio Land, we also provide a system called the metric system. It's collecting various health information, but also like a pressure, workload information, and also operations information, very useful for debugging and monitoring and see how heavy the workload is on Alluxio. And we provided several sync for this metric system already, but you can also leverage the sync to build some external monitoring system or integrate with some other monitoring system. I just pasted on the Slack channel a blog we published last week. How to one of our engineer talks about how to create Grafana data dashboards to visualize the Alluxio metrics, and from there you can just also monitor the healthiness of the Alluxio cluster.
As we have more questions coming in via the GoToWebinar question panel, I highly recommend checking out Slack because we are coming close to an end. And we're very active on Slack where you'll find folks like Ben, Nakkul, and other Alluxio PMC maintainers and experts who can continue the discussion there. In the meantime, our next question is, how does Alluxio compare to MRFs?
I think, Ben, do you want to
Yeah.
this one?
Yeah, this is a good question. MRFs is something you can get for free from EMR installation, and this is a Hadoop compatible. So you can pretty much just think of this as an on-cloud version of the Hadoop and working or integrated deeply with Hadoop with EMR stack. So we see a lot of cases people are running big data EMR workloads by first copying data to EMRFS and then make some process and writing to EMRFS and then dumping the data from EMRFS to S3. So with Alluxio, there are two major differences here. One is Alluxio can be used as basically not a separate system from S3, but you can think it's a layer on top of S3. You can set different write modes as I mentioned before, as the blog post talked about. You can use Alluxio as a transparent layer on top of S3. You can control how you want to write through this layer, or you can just write only to this layer, or write to this layer but asynchronously put data to S3. Or on the read side, you can also read the dirty data from Alluxio, but also read the entirety of data through Alluxio get from S3 too. So these two works really, really well together rather than putting another system here. And also, this also saves you time or the efforts to migrate data from one system to another. So basically, by controlling the read type and the write type, Alluxio itself is able to help you migrating the data and putting the data in sync with the S3 if you treat S3 as a data link. This is one difference. The other difference is Alluxio can run outside EMR, which is not the case for EMRFS. So we do see people running Alluxio as a standalone service and let different short-lived or ephemeral EMR clusters all talking to the same Alluxio standalone Alluxio cluster. And in this way, they can share the hot data without putting the data repeatedly from S3 to their individual EMRFS. So I would say this is the difference. And also in a later release, we are going to get more and more features. Alluxio itself is evolving very, very fast. We just released our 2.0 2 months ago, and now we're having next release 2.1 coming in in September. We're going to have a lot more new features. So I would say in feature-wise, we're adding a lot more to Alluxio rather than just like Hadoop compatible interface.
Great. Well, thank you, everybody. Thanks to our hosts and speakers, Ben and Nakkul. This is a wrap for us today. If you have any other questions or want to continue your discussion, friendly reminder to check out the community Slack channel, which is alluxio.io/Slack. And again, here you can feel free to bring any of your questions and engage with Alluxio experts. I also want to mention that we are thrilled to share that we will be having the first ever Alluxio community conference towards November of this year. Please stay tuned, and we will be launching the website with more details to come. Thanks, everybody. This concludes today's office hour.